Welcome to the Mood Ring Part 1 Exploring Color. In this video, we will be covering Activity 5, found on page 1.31. The topics of the video will include what is an LED, how does one work, and how is the color LED built into the hub. This should be an exciting exploration of science and engineering. Take a moment to navigate to the activity using one of the familiar methods we've learned in previous activities. You'll probably find it on page 1.31. I'll see you there. Activity 5. Before we get started looking at the LED simulation on the next page, let's take a look at LEDs in general. What is an LED? Well, first let's know what LED stands for. LED is an acronym for Light Emitting Diode. Well, a diode is a special semiconductor that you'll learn more about when you take physics or engineering in the future. For right now, let's just think of it as a special kind of a light bulb. You'll see that I have a blue LED, a red LED, a green LED, and also this white looking one which actually has 4 wires coming out of it. This is a composite LED with all 3 of these built in. It's called an RGB LED, and it's really just like the one that's on the hub. It's just that the one on the hub is smaller and in a different kind of package. But let's take a look at what an LED is. I'm going to take just one of these, and I'm going to try to turn it on with this battery. I have a battery here that is 2 AA batteries, and their voltages add up together, making it about 3 volts, which is enough to turn this on. So I'll go ahead and plug this in, and you can see that it makes blue light. Now, the blue does not come from the fact that it's a blue case. This blue case is just helpful for engineers to recognize what kind of LED they have. The blue comes from the actual way that the light is being made inside of the device. It has nothing to do with this coloring. You can actually buy blue LEDs that have a clear case. It's just that a blue LED with a clear case looks like all the other LEDs, which is confusing. And so this is a blue LED, and here is the RGB LED, and I'm just going to hook up 2 of the 4 wires. The longer one here is common among all 3, and when I plug that in, I see that it's red. So let's learn more about how these LEDs work. Okay, let's do a little experiment to observe how an LED works. I have a RGB LED connected, and there's that one common lead that is connected to the negative or black of my battery. There's also a lead that turns on the red LED, a separate lead that turns on the green, and a third that turns on the blue. Well, let's give this a try. Remember that batteries are a source of electricity, and that electricity is really just a flow of the subatomic particle called an electron. And so I'm going to make electrons flow through this LED by touching the red wire to the red lead. Notice that it's bright red. When I lift the crocodile clip off the lead, it interrupts the flow of electrons through this LED, and the light goes off. Again, I'll touch the green. Now electrons are flowing out of the black through the LED and back in here. And the electrons are giving off their energy that are stored in the battery. Here I'll try the blue. Sure enough, it's blue. Now, remember that we said that the electrons are moving through the LED. Here's another electrical component called a resistor. Well, you might guess that a resistor, well, it resists the flow of electrons. And so I've connected a resistor into my circuit. So let's try the experiment again. I'll touch it to the red lead, and what do you notice? It's not as bright, is it? I'll get rid of the resistor just to compare. There it is without the resistor. There it is with the resistor. So when the electrons have to move through the resistor, the LED is dimmer. Again, I can try the green, and I can also try the blue. Again, without the resistor, with the resistor. Without the resistor, with the resistor. Well, let's see if we can explain these observations with a little bit of a theory of how LEDs work. Let's review the electromagnetic spectrum. Recall that electromagnetic radiation is a wave in the electric and magnetic fields of space, and that these waves have a wavelength, that is, the distance between two peaks. As we move from the left to the right on the electromagnetic spectrum, notice that the waves become shorter. Notice also that in the visible region of the spectrum, light goes from red on the left to blue on the right. And so as we go from left to right on the spectrum, the wavelength becomes shorter. But there's another feature that changes. Remember me telling you that ultraviolet light, that's the light that's up above violet on the visible spectrum, is a very high energy light that actually can be used to sterilize, that is, kill bacteria. And we know that X-rays are still even more powerful. X-rays can actually be used to start energetic nuclear reactions. They penetrate our flesh and image our bones. And gamma rays are extremely high energy electromagnetic waves that can do much damage, particularly to astronauts in outer space. Well, one of the principles of physics is that as wavelength becomes shorter, the amount of energy in the wave becomes greater. So blue light has more energy than red light. Well, if blue light has more energy than red light, how do engineers make LED devices that make red, green, or blue light? Well, somehow they must make a device where the LED gives off higher energy light for blue and lower energy light for red. But how does that happen? Well, remember our experiment. Remember that we allowed electricity, which is made up of electrons, to flow through the LED device in something we call a circuit. And that when the electrons flow through the circuit, light is made. Similarly, we found that when we resisted some of the flow of electrons, that is, made fewer electrons flow through the circuit, that it was actually dimmer. So what's going on inside of that light-emitting diode device? Well, inside of that device is something called a semiconductor. And a semiconductor, you can think of, is a material that has holes that electrons can fall into. Well, here's a little analogy that I made for you. Imagine a rock falling down into a deep well and a shallow well. If you take a rock and drop it into a shallow well or just a hole in the ground, it will make a noise. And that noise is represented with the little sound waves coming off the side of the hole and the rock hitting it. If, however, you were to drop the same rock into a deeper hole, a louder sound would be produced. If that sound was similar to the energy in light, If we were to drop an electron in a shallow hole in the semiconductor, it would give off light with a little bit of energy. If we were to drop it into a hole that is deep, the LED would give off a lot more energy, which would be a more blue color. Now, remember, the number of electrons that flow through the device determines how bright it is. And that's just analogous to dropping more rocks into the hole. Dropping more rocks into the hole does not make the hole deeper. Dropping more rocks just makes the sound louder because there's more rocks hitting the ground. So I hope this analogy helps you to understand a little bit of how an LED works. Let's do a quick review. LED is an acronym for light emitting diode. LEDs are made in different colors. You can have red, green, and blue, and each LED has a single color that it makes. The red, green, blue LED that we work with is because there are actually 3 LEDs built in. Red light is long wavelength and blue is short. Long electromagnetic wavelength is low energy and short is high. Remember talking about ultraviolet and X-rays? Red light is produced when electrons fall into shallow holes in semiconductor material. Remember looking at rocks falling into a hole making noise and saying that electrons are similar, it's just that they make light. Blue light is produced when electrons fall into deep holes in semiconductor material, just like dropping a rock into a deep hole makes a loud sound. The more electrons falling into the holes makes the light brighter. We saw that when the resistor was put in the circuit, the light is dim. That's because there aren't as many electrons falling into the holes in a given period of time. So I hope this review has helped to summarize what we've learned. Activity 5. Now that we've learned about how LEDs are actually made by engineers and a little bit of the science on how they work, also take a moment to reflect on all of the different things that we've learned in this entire mood ring activity. You've learned how to write a Python program that uses the color.rgb command to make all sorts of different colors. You made primary colors, secondary colors, you made bright white light and gray light and dim gray, and you even learned how to turn it off and make it black. Remember that as we changed those numbers, what we're really doing is changing the number of electrons that flow through each LED in that composite color LED that's built onto the hub. Let's take a close-up look at the hub and zoom in and take a look at the color LED. And then we're going to do a little simulation that shows us how that color LED works using the software commands that we've learned, the color.rgb. So take a moment to study the image of the zoom in, and then let's switch to the next page. To go to the next page, press Control, touchpad to the right. Here I am with a zoom in of the color LED on the hub. You can see that this LED is something called a surface mount LED, and it's a different kind of package than what I showed you earlier. It's very small. You can put many of these LEDs in the size of a postage stamp or your thumbnail. They're very, very small, and you can see, looking on your hub, just what their size is. Now, notice that up here at the top is the command, color, and we did this with color.rgb. We set it to 000, and we said that's off. Well, notice that when we set it to 25500, it just turns on one of the 3 LEDs that's actually built into the color LED, the RGB LED. Here we see the red segment on. If I change the software again to green, 02550, that basically means just don't let any electrons flow through the red or blue LED. Just let them all flow through the green LED. Similarly, blue, that 255 on that last number, means let all the electricity flow through the blue LED and none through the red and blue. But what happens when we turn on two at one time? Well, if I turn on red and green at the same time, that red and green light mixes actually in our eye, and we perceive it to be a different color called a secondary color, a yellow. Similarly, if I turn on blue and green, I get cyan, again a secondary color. This is happening actually in our eye though. Magenta is produced when I turn on the red and the blue using the values 255, 255. And lastly, white light happens when all three colors hit our eye at the same time. That makes white light, 255, 255, 255. Notice when I reduce that to 128, 128, 128, what it's really doing is just reducing the number of electrons that flow through each of the three LEDs, making it lighter. So here we've had a good little exploration of how light is made in the color LED. This concludes Activity 5.